All right, seventh graders, welcome to the class notes for this week on the periodic table. As we go through this, hopefully, if everything worked out the way I was hoping it would work out, this will just be review and kind of just confirming what you put into your projects for last week. Maybe there were some things that you put in there that you didn't completely understand, so hopefully by watching this and hearing me explain it, it might tie up some of those loose ends for you so that you understand it even a little bit better. If after this video you're still a little bit confused about things, make sure you come and see me. Reach out to me in an email to set up a time to meet with you, or come into my office hours to talk about it. A couple of you came into office hours last week. I was actually surprised that there were not more of you in office hours last week, thinking that there might be parts of these in terms of the organization of the periodic table that were a little bit confusing, that you might have needed a little bit more help on. I don't know. Maybe you guys watched the Khan Academy video. I think that one did a really nice job. If when you went through the reading, it was hard to understand a little bit through your reading comprehension, that maybe the video helped you. I'm not sure. So let's go through this and talk about it here, and I'll kind of relate it to parts of your project as well. So, Dmitriev, Mendeleev, right? He's credited with the periodic table. You saw the Ed puzzle this week that spent a lot of time going through a little bit of the history of that. There was just a short little section in your project that you needed to mention his name and understand the late 1800s, or mid to late 1800s is when this was all happening. Okay? He did by increasing mass, right? And what he ended up seeing was that when he did that, he found out that elements with similar properties ended up being in the same columns. And even though not all the elements were yet discovered, he knew that if he filled in the blanks and put some blank ones in there, that it was very predictable in terms of the organization. And so, like it showed you in that Ed puzzle, there's that kind of that funny story with that French scientist that thought he discovered an element, and Mendeleev was pretty much telling him, no, you're wrong, even though he had not even looked at any of the data, but just because it didn't fit the model for the periodic table, and he was so sure of it, and he was right. And so it's really amazing when you think about how it almost seems like a coincidence, but it's not. It's science. Of how when you put them in order, and then the atomic numbers then, which the number of protons also then increase in order, and then properties line up in the columns, the up and down. It's just it's pretty quite remarkable for science, and it's an amazing tool that is important as you move forward in your science. You'll use it next year for biology, and then of course some for chemistry when you get into high school. All right, so periodic law. Oops, I didn't realize these were all out there at once. Okay, so just kind of type as I go, okay, so that you're listening to me. Or pause and just listen to me, and then when I go to the next slide, pause it and type in everything, however you want to do it. But make sure you're listening to me here. All right, so the periodic table, one of the ways that it's arranged is not by atomic mass, but by increasing atomic number. And the atomic number is the number of protons that is in the nucleus, right? And so that's one of the ways that it's organized that you guys hopefully put in your project. The periodic law is that the properties of the element are actually these periodic functions of their atomic number. And so what that means is that as you go across a row, which is a period, the properties change, okay? But then when you go down to the next row, those chemical properties repeat. And it's kind of like the keys on the piano, like when you go from, oops, that's going to mess me up. Okay, C, D, E, F, G, A, B. Then you go back at the next octave here, and now you're back at C, and then C, D, E, F, G, A, B, and then back to C, D, E, F, and over. The same thing happens as you go across the periods, and that's what the periodic law is saying, that it repeats that pattern over and over, okay, over and over. One of the fun things with the periodic table are these element songs. So there's a couple of them. that if you search for them, that they're kind of entertaining to watch. I had this one that was linked here. I'm not going to play it just because otherwise this video will get super long. Of this girl, I think she's in 2nd grade, and for her talent show for her school, she sings the periodic table song, and she has it all by memory, and it's really cute and it's kind of funny. So if you're looking for something, search up those element songs in Google, and you'll find a couple different ones, and they're kind of entertaining to listen to. All right, moving on to the next part of your notes, the organization of the periodic table. So we already talked about in the previous slide with periodic law that one of the ways that it is organized is by increasing atomic number. So hydrogen is number 1, helium 2, lithium 3, and then as you go across from left to right, and then as you move down the table. The other way that it is organized is by some of those physical properties, okay, and what they represent. And so on the left side of the table, and with my video, everything's always kind of backwards, mirrored backwards, so whatever. On the left side of the periodic table, you have the metals, and you notice that they are here in green. Right side are the nonmetals, and then you have this staircase where these purple elements are that are the metalloids. So the majority of elements are metals. Most of these transition metals here in groups 3 through 12 are extremely similar to each other, okay? And so there's not a lot of differences between them. That even includes these 2 rows that are down here. The only reason these are even down here is because they get pulled out of row or period 6 and 7 just to make the periodic table fit better on a piece of paper. Otherwise, these last 2 rows would be double the width practically, and then they would shrink it and make it all kinds of craziness. So they just pull those 2 out. So not a lot of differences between these, but in group 1 and group 2 and in group 17 and 18, you have lots of differences, and we'll talk about those here in a moment. Metals on the left side, nonmetals on the right, and the way you distinguish the left side and the right side is by this staircase of metalloids. So when we say the left side of the table, we just mean left of this staircase. Right side of the periodic table, we just mean right of the staircase. It's not in the middle of the periodic table, obviously. Okay, so that's why we have more metals, less nonmetals, and then just a few metalloids. So metals. Some of them are the metals that you normally think of, the solids that are used for construction and other things. They're good conductors of electricity. They're good conductors of heat. That's really important for us, like it said in that Edpuzzle video. For the most part, they're solids at room temperature. The only exception is Hg. And if you know what that is, say it out loud. Oh, I heard someone say it. Mercury. Just kidding. I didn't hear anybody. Okay. They're malleable, meaning that you can shape them by hammering them, by melting them, and then putting them to cast them into things. So that's really important for construction and for materials. Ductile is the ability to be made into wire, drawn out into wire. And so again, that's really important for us because they're good conductors of electricity, that we can make them into wires and be able to use for our electrical wires. Okay, the nonmetals, they're pretty much the opposite. They are poor conductors of heat and electricity. Most of them are gases. There are some that are solids, and if they're solids, they're not malleable. They're not ductile. Okay, they're extremely brittle, meaning that you can't really shape them. You try to shape them, they just break. Okay, like glass is brittle is an example. Not that glass is an element, but that's an example of something being brittle. And then you have the metalloids. Okay, and the metalloids. Let me move myself here. Metalloids have properties of both. Okay. They share some properties of metals and nonmetals. And depending on which element it is, it might have certain characteristics of metals and not many characteristics of nonmetals. And then another one of the elements that's a metalloid might be the opposite, where it shares a little bit more in common with a nonmetal and less with a metal. They vary. All right. Silicon is a really important one. I think he talked about it in the Edpuzzle as well, because that's one for computer chips. They're semiconductors. That's really important for processors and things in our computers. and phones and things like that. So metals, nonmetals, metalloids is the second way that the periodic table is organized. So you have the periodic table, it's organized by atomic number as one way, and then it's also organized by metals, nonmetals, and metalloids. And then the third way are by the periods and the groups or families. Okay? Periods and families, or groups and periods, however you want to say it. All right, periods, horizontal rows. Here's how I remember that periods go across instead of up and down. I write in sentences across from left to right, and I end my sentence with a period. So periods go across. There are 7 periods in the periodic table. As you move across, the properties change. They do not share properties in a period. They change as you go across the periodic table from left to right. The thing that does stay the same is the atomic number of, the same number of atomic orbitals, okay? Same number of atomic orbitals. So in other words, energy levels, okay? I'm going to show it to you in the next picture if you don't understand that, but that means the last level where electrons in the electron cloud are flying around the nucleus, there's different levels. In a period, if you are in the first row, period 1, that means you have 1 energy level. If you're in period 2, which is row 2, you have 2 energy levels. If you're in row 7, period 7, that means you have 7 energy levels. And an energy level is just another way of describing what atomic orbital is. Okay, the other thing, not that important for us, and I don't even think it was in any of the stuff for your projects, is this thing called atomic radius. So the atomic radius would be from the nucleus, which is in the center of the atom, to the very outside of the electron cloud, the outermost layer. And that would be a measurement. And so the atomic radius decreases as you move from left to right. And again, I'm backwards. From left to right across the periodic table. All right, I put that picture in there for you. So those are the periods there. Notice period 6, blue. This is also counts as period 6 down here, the lanthanide series, and then 7, actinide series. Down here is part of period 7. All right, so here's what I mean by that. Take a look. In row 1, so the inner circle here is representing the nucleus, okay? And so the outer circle around it is the orbital or the energy level, all right? And so you're in period 1, so there's 1 energy level around the nucleus, okay? 1 energy level. Over here, you're in row 2. Now you'll notice there's the nucleus. Now you have 2 energy levels, and that's the same all the way across the period. Period 3, same thing. 1, 2, and now 3 energy levels, or orbitals, okay? And so that goes all the way across as well. Notice, okay, these red dots, those are called valence electrons that we talked about before. Valence electrons are the special electrons that are in the outermost orbital, or the last energy level. That's valence electrons. So notice they do not have the same number of valence electrons in the period. So even though they have the same orbitals, or the same energy levels, the same number of valence electrons is not true for a period. Okay? Now, if you remember from your project, and what I'm going to talk about in my next slide, groups or families, as they are the columns, notice what they do have in common. They have the same number of valence electrons. So if you're in group 1, you have 1 valence electron. If you are in group 18, which is also known as 8A, and we'll talk about that in a second, you have, there's a 2 here, but then from everywhere else, it's 8, because that because your outer shell is always filled in this last column. And so the most you can have in that first orbital or that first energy level is 2 electrons. After that, the most that you can have on any other level is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And even though this has a third energy level, 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Okay, so there's a picture I put on there. Okay, we didn't talk much about these transition metals. In fact, that last picture is just the first 3 periods, and so it doesn't even have any of these transition metals here. Okay, and that's like they said in the Ed puzzle, they're so similar to each other that's why they're kind of just grouped together, and there's not a lot of difference between them where you have these differences across. All right, so there are 8 main columns and 10 transition columns. So these are the 10 transition columns. These are the main 8 columns. All right, and so that's when on that previous slide where it said we're talking about group 18, even though it said 8, it's because it's one of the 8 main groups. Okay, and then we just kind of lump those 10 transition ones just together because they're pretty much exactly the same. All right, so what happens in a group? Well, another name for a group is a family, and this is a perfect reason why. Families have very similar characteristics, right? You guys might not want to admit it, but you look like your siblings, you might act like your siblings or your parents and things like that, right? Because that's part of heredity. So that's what families in the periodic table do as well, the groups. They're vertical columns, and they have the same chemical properties. And the reason they have those chemical properties is because they have the same number of valence electrons. And so if they have 1 valence electron in that outermost layer, they're highly reactive because it's super easy for them to get rid of that one. And that's why the alkali metals here, they're super reactive because they have 1 valence electron. And so they just get rid of that all the time. And so they're reacting with all kinds of stuff. Group 18 or 8A over here, they have every single valence electron they need to fill that outer layer. And so they do not react with anything. They're the most stable of all the elements because they're already filled. Those last layers are filled with as many electrons as they can have. So they're not very reactive. Whereas the one right next to it here, the halogens are 1 short of having a full outer layer. And so they too become super reactive, and because they're looking for that 1 more electron to fill their outer layer. And so they're super reactive, and they're really reactive here with these alkali metals because they're looking to get rid of 1, they're looking to pick 1 up. Okay? As you move down the column, they become even more reactive. Okay, so the reactivity increases as you move down the group. Okay, so the 3 ways the periodic table is organized is by atomic number, groups and periods, metals, nonmetals, and metalloids. I think the most confusing of all those is making sure that you understand the difference between periods and groups and how it works with the periodic table. So again, office hours Monday through Thursday, 1 o'clock to 2 o'clock. If you want to come in and just talk through it with me at all, if you just want to make sure that you got it. Okay. All right. Hopefully you had a good week, and hopefully I get to see you soon. Take care.